Hi, I'm Dr. Kara Wells presenting video data reveals bovine embryo stress in response to fluctuations in ambient room temperature. Numerous studies have demonstrated that maintenance of rigid temperature control is critical for the development and competence of preimplantation embryos. Yet, in the field of conventional embryo transfer, in which we collect and transfer in vivo derived or IVD embryos, much of the work is not performed in a temperature controlled environment. In conventional embryo transfer, embryos are flushed from the in vivo environment of the donor, which should consist of an internal body temperature of about 38 degrees Celsius, into a collection filter and then transported into a laboratory in which the embryos are held at room temperature. This common procedure rapidly transitions the embryo from a 38-degree environment to room temperature, which is typically much cooler at 22 degrees Celsius, possibly inducing stress and damage to the embryo, which can reduce the likelihood of the embryo to result in live birth. Previously, our team has developed methods to evaluate the embryo's real-time morphokinetic activity, which is thought to be a reflection of embryo metabolism in real time. We do this by applying graphic image processing techniques to short videos of embryos and quantifying how the embryos change frame by frame. Therefore, the objective of this study was to use graphic image processing to measure real-time bovine embryo morphokinetic activity as the embryo transitions from 38 degrees to environmental room temperature. In study 1, data collection spanned 5 months. 95 embryos were collected from Holstein donors during routine practice during this time. After embryos were located, embryos were placed in holding media. Up to 6 embryos were arranged in the dish so they were not overlapping, and a 30-second video of the embryos was recorded. All embryos which were eligible for transfer were immediately transferred into eligible recipients. Pregnancy outcomes were confirmed 35 days post-transfer by ultrasound. To analyze the videos and quantify embryo morphokinetics, videos were uploaded into Envision software, which is a web-based platform produced by Genesis. In Envision, video graphic image processing techniques, including object detection and image subtraction, were applied to quantify image pixel change over time. The pixel change was used to infer the embryo's morphokinetic activity. Morphokinetic activity, expressed as mean pixel change, was compared to the observed pregnancy outcomes. In study 1, 36 out of 95 embryos established a pregnancy. Media temperature ranged from 22.8 to 32.7 degrees, which was a reflection of the ambient room temperature of the lab. Interestingly, we observed an inverse relationship between the embryo's morphokinetic activity and temperature. Embryos showed greater activity at cooler temperatures and less activity at warmer temperatures. This data was strongly correlated at 22 to 24 degrees and 30 to 33 degrees. Interestingly, there is more variation at 25 to 28 degrees Celsius. You can see here that some embryos remain quiescent, similar to that of the embryos held at temperatures closer to body temperature, and some embryos demonstrate a sharp spike increase in temperature. When this is compared to pregnancy outcomes, we see that embryos that maintain the more quiescent state establish more pregnancies. To further study this phenomenon, we classified the embryos according to the temperature and pregnancy outcomes. We see that in this critical inflection point of about 24 to 28 degrees, embryos which maintained activity levels comparable to that of embryos cultured in warmer temperatures made more pregnancies. These outcomes suggest that embryo stress in response to environment in real time can be detected with Envision and can reveal critical indicators of embryo competence. We decided to repeat these methods in the in vitro embryo model. In study 2, 337 embryos were shipped fresh to our study site by commercial air. The embryos' time in transit spanned from 8 to 30 hours. Once embryos were received, temperature of the media was recorded immediately. Once embryos were identified, sorted, and graded, a 30-second video of the embryos was recorded on a 4K view camera. Embryos were then transferred into eligible recipients, and pregnancy outcomes were determined by ultrasound. The same video analytic methods were applied. In study 2, we found that 187 out of 337, or 55.5% of embryos resulted in a pregnancy. Temperature ranged from 25.9 to 37 degrees Celsius at study site arrival. While we see a slight negative trend, the embryos with more morphokinetic activity levels decrease as media temperature becomes warmer. But we did not see significant differences in the embryo's morphokinetic activity based on temperature. It is hypothesized that these embryos did not show differences as they had 8 to 30 hours to acclimate to the changing environment before arrival at the study site, and researchers were unable to capture the embryo's response to environment and stress acutely. Had we captured the embryo videos at the onset of the temperature change, it is possible that the results would have shown different embryonic responses. In conclusion, graphic image processing techniques supported by Envision are effective in capturing an embryo's response to environment in real time. These changes may be indicative of embryo competency and likelihood of the embryo establishing a pregnancy, and can be used to detect subclinical signs of embryonic stress and select hardy embryos robust to temperature fluctuations. Thank you.